Hi everyone, my name is Taylor Clark, and today I want to share some research on a technique called gas chromatography paired with vacuum ultraviolet spectroscopy, GCVUV for short. This method has some great advantages over traditional techniques like gas chromatography mass spec and liquid chromatography mass spec, specifically when it comes to telling apart compounds that look very similar. The studies that I'll be talking about come from researchers like Legessa, Scoltetti, and others who have explored how GCVUV is being used in forensic and pharmaceutical sciences. In order to prep the samples, they use a derivation step where they were able to make the compounds more volatile and help prevent thermal breakdown. They heated the samples at 70 degrees Celsius for 30 minutes before injecting them into the GC system. For biological samples, however, they had to first extract them using liquid-liquid extraction with ethyl acetate, followed by centrifugation and filtration before they were able to derivatize the samples. For instrumentation, they worked with an Agilent 7890 GC system and a VGA 100 VUV detector using a DB5MS capillary column. The injector was set at 280 degrees Celsius with a 10-1 split ratio, and helium was used as the carrier gas. The oven followed a temperature ramp starting at 100 degrees Celsius, climbing to 200 degrees Celsius at 20 degrees per minute, and then reaching 280 degrees at a slower rate, where it was then held for 5 minutes. The detector scanned from 120 to 240 nanometers every half second, giving high-resolution data to help separate the similar compounds. What's really cool about GCVUV is how well it differentiates cannabinoids and their metabolites. Each compound had a unique fingerprint in the spectrum, making it much easier to tell apart. Plus, since VUV spectroscopy has built-in separation capabilities, we don't always need full chromatographic separation, which speeds up the analysis process. For designer drugs, GCVUV was useful in distinguishing isomeric stimulants. These compounds are normally not able to be differentiated using mass spec alone. For example, the GCVUV separated the synthetic cathinones, which is a really big advantage in forensic analysis. The combination of its high spectral resolution and its separation capabilities played a huge role in identifying and quantifying these substances. Overall, multiple studies have shown that this technique provides unique spectral fingerprints that help with compound identification, even when chromatographic separation isn't perfect. It's proving to be a valuable tool in forensic and pharmaceutical science, particularly in identifying compounds with very similar structures. It makes data analysis much more straightforward compared to gas chromatography triple-quadruple mass spec, even though its sensitivity for biological samples still has room for improvement. Moving forward, I would suggest that research focus on enhancing the sensitivity and expanding its applications in forensic and pharmaceutical applications. I'd like to give a big thanks to the researchers whose work made this presentation possible, including Dr. Legessa, Dr. Scoltetti, and my PI, Dr. Shug, along with their teams for advancing this research. And of course, I want to thank all of y'all for listening. I'll be happy to take any questions if you have them.